Hello friends, myself Professor Joshi VM from ADSUL'S Technical Campus, Chas, Ahmednagar. Today we conduct a second experiment of electrical machine subject, that is polarity test. Okay, the aim of our experiment is aim of our experiment is polarity test on single phase transformer. Okay, so what is the objective of our experiment? To decide the phase and neutral terminal on HV and LV side. We know that while when the transformer is manufactured, so we cannot find out the exact polarity, that is phase or neutral of neutral terminal of a transformer. So by using this test or this method, we can find out the phase and neutral, that is positive and negative terminal of the transformer. So the apparatus required for this experiment is apparatus required for this experiment is single phase transformer, next voltmeter, and third is phase variac. The rating of transformer is 1 kVA, 230 by 115 volt. The voltmeter is 0 to 150 and 0 to 300 volt. The phase variac is 240 upon oblique 270 volt. Okay, then what is the need of this experiment? On the primary side of two winding transformer, one terminal is with respect to other terminal at any instant. At the same instant, one terminal winding is with respect to other. The relative polarity of primary and secondary terminal at any instant must be known if the transformer is to be operated in parallel or is to be used in polyphase kit. So here we have to take an A1 and N terminal, that is not given on the transformer. We will give we assume here A1 terminal and A2 terminal. For this test, two terminals at LV and HV winding are short circuited. So voltmeter connected between other two terminal will shown the resultant if it is shown E2 opening. So short circuit point at LV winding will be indicated by which is a 2 point, A1 and A2. A2 is negative if voltmeter reading is terminal is connected to the A1 and A2 respectively. This shows the positive and negative are marked as A1 and A2. So we have to take two types of test. We have find here two types of results. First, adhesive polarity and subtractive polarity. So we observe here subtractive polarity circuit diagram. We have to connect as per this circuit diagram auto transformer to 30 volt. Here one side of winding is marked as A1, A2, other marked as small a1, a2, and here the windings are short circuited by using the voltmeter. Okay, and this point is short circuited for the subtractive polarity. Okay, for the adhesive polarity, for the adhesive polarity, we have to draw this kind of circuit diagram. Here we mark A1 point and A2 point. After that, small a1 point and small a2 point. Then what is the procedure to find out the polarity? For this procedure, we have to keep supplying off position After that, do the connection as per the circuit diagram by connecting A1 and A2. Then variac at its minimum position. Then switch on the supply. Increase the output voltage by using the variac gradually up to the 50% of its rated voltage. We have to increase the voltage. Then we have to measure the primary voltage V1 and voltage between A1 and A2. Voltage between A1 and A2. We have to measure the voltage by using the voltmeter. Okay. Then compare reading of voltmeter connected across the primary and connected between A1 and A2. So A1 and A2, we have to compare these two voltages. Okay. Then if the V1 is greater than V2, if the V1 is greater than V2, the polarity is subtractive polarity, and otherwise it will be adhesive polarity. Okay. After that, switch off the supply. So for this experiment we have to draw the observation table. So while doing experiment, I observe here for the adhesive polarity. Primary voltage V1, secondary voltage V2, and total voltage VT equals to V1 plus V2. Primary voltage reading is 60 when secondary voltage is 30 and the total is 90. When the primary voltage is 80, secondary is 40, then the total is 120. When the primary voltage is 100, then the secondary voltage is 50 and the final voltage is 150 for the adhesive polarity. Means for adhesive polarity we will take reading here and here also. Okay. When the primary voltage is 60, then the secondary voltage found at 30. When the primary voltage is 80, then the secondary voltage is found at 40. When the primary voltage is 100, then the secondary voltage we will found here 50, and the addition of both the voltages we found here, that is 90, 120 and 150 volt here. Okay. This is procedure for the adhesive. For subtractive we have to find the observations. Observations for subtractive, same we have to draw same observation table V1, V2 and total voltage VT equals to V1 minus V2, because this is a subtractive polarity. So if we found primary voltage is 60 and secondary is 30, then on the total voltage we found 30 volt. 60 minus 30 equals to 30 volt. After that, primary voltage is 80, then the secondary is 40, and while the total voltage we found 40 volt. When the primary voltage is 100, secondary is 50, then at time we will found the total voltage 50 volt. So by using this method we find out the polarity of single phase transformer. Why this polarity we have to take on the primary side of two winding transformer. One terminal is respect to the other terminal at any instant. At the same instant, one terminal winding is with respect to other, the relative polarities of the primary and secondary terminals at any instant must be known. If the transformer is to be operated in parallel or to be used in polyphase kit, we have to know the polarity of the transformer. If we know the polarity of transformer, then only we can connect the transformer in parallel to transformers in parallelly with exact polarity. And for other purpose like polyphase transformers means, if you have to connect three transformer parallelly, two transformer parallelly, we must know the polarity of the transformer. If we know the polarity of transformer, then only we can connect two or three transformers parallelly. Here we mark on terminals A1 and A2 and small a1 and small a2 to find out the exact polarity of the transformer. Why we mark a1 a2? Because we don't know the exact polarity of these terminals. So we mark here a1 and a2, small a1 and a2. So by using this experiment we can find out the exact polarity of the transformer. Okay, then what is the conclusion of this experiment? Conclusion of this experiment: when polarity of transformer is opposite, the voltage across winding is adhesive. Adhesive in nature. And second conclusion: when current polarity of transformer are same, then the voltage across winding is subtractive in nature. So this is we concluded by using this adhesive and polarity. But while doing this experiment we have to know exact difference of between two circuit diagrams. So here I show you both the diagrams to find out the exact circuit difference between them. Okay, here we short circuited the terminals of primary and secondary, and in this case we short circuited we short circuited this line with this neutral winding, and the voltmeter is also connected with this point. Okay, to find out the exact polarity by using adhesive polarity and subtractive polarity, we have to know the exact difference between two circuit diagrams. Okay, so this voltmeter reading and this voltmeter reading is very important while find out the exact polarity of circuit diagram. If the primary voltage and secondary voltage shows the addition or show the sum V1 plus V2 equals to total V, then this polarity is called as adhesive polarity. If the V1 minus V2 shows the total voltages, then this type of polarity is called subtractive polarity. Okay, so we have to know the exact meaning of adhesive polarity and subtractive polarity, and we have to find out this polarity to connect the transformer winding connection, and for to connect this type of transformer with parallel with another transformer. So this experiment is very useful to connect the perform to perform the parallel operation of transformer. Thank you.